All right, welcome to the GROK 4 release here. This is the smartest AI in the world, and we're going to show you exactly how and why. It really is remarkable to see the advancement of artificial intelligence, how quickly it is evolving. I sometimes compare it to the growth of a human and how fast a human learns and gains conscious awareness and understanding. And AI is advancing just vastly faster than any human. I mean, we're going to take you through a bunch of benchmarks that that GROK 4 is able to achieve incredible numbers on. But it's actually worth noting that GROK 4, if given like the SAT, would get perfect SATs every time, even if it's never seen the questions before. And if even going beyond that to say like graduate student exams like the GRE, it will get near perfect results in every discipline of education. So from the humanities to like languages, math, physics, engineering, pick anything, and we're talking about questions that it's never seen before. These are not on the internet, and GROK 4 is smarter than almost all graduate students in all disciplines simultaneously. Like, it's actually just important to appreciate that's really something. The reasoning capabilities of GROK are incredible. So there's some people out there who think AI can't reason, and look, it can reason at superhuman levels. So yeah, and frankly, it only gets better from here. So we'll take you through the GROK 4 release, and show you like the pace of progress here. I guess the first part is like, in terms of the training, we're going from GROK 2 to GROK 3 to GROK 4. We've essentially increased the training by an order of magnitude in each case. So it's 100 times more training than GROK 2, and that's only going to increase. So it's frankly, I mean, I don't know. In some ways, a little terrifying, but the growth of intelligence here is remarkable.
Yes. It's important to realize there are two types of training compute. One is the pre-training compute. That's from GROK 2 to GROK 3. But from GROK 3 to GROK 4, we're actually putting a lot of compute in reasoning in RL.
Yeah, and just like you said, this is literally the fastest moving field. And GROK 2 is like the high school student by today's standard. If we look back in the last 12 months, GROK 2 was only a concept. We didn't even have GROK 2 12 months ago. And then by training GROK 2, that was the first time we scale up like the pre-training. We realized that if you actually do the data ablation really carefully, and the infra, and also the algorithm, we can actually push the pre-training quite a lot by amount of 10x to make the model the best pre-trained base model. And that's why we built Colossus, the world's supercomputer with 100,000 H100. And then with the best pre-trained model, and we realized if you can collect these verifiable outcome reward, you can actually train this model to start thinking from the first principle, start to reason, correct its own mistakes. And that's where the GROK 3 reasoning comes from. And today we ask the question, what happens if you take the expansion of the Colossus with all 200,000 GPUs, put all these into RL, 10x more compute than any of the models out there on reinforcement learning, unprecedented scale, what's going to happen? So this is the story of GROK 4, and Tony, share some insight with the audience.
Yeah. So yeah, let's just talk about how smart GROK 4 is. So I guess we can start discussing this benchmark called Humanities Last Exam. And this benchmark is a very, very challenging benchmark. Every single problem is curated by subject matter experts. It's in total 2,500 problems. And it consists of many different subjects: mathematics, natural sciences, engineering, and also all the humanities subjects. So essentially, when it was first released, actually like earlier this year, most of the models out there can only get single-digit accuracy on this benchmark. Yeah, so we can look at some of those examples. So there is this mathematical problem, which is about natural transformations in category theory. And there's this organic chemistry problem that talks about electrocyclic reactions. And also there's this linguistic problem that tries to ask you about distinguishing between closed and open syllabus from a Hebrew source text. So you can see also it's a very wide range of problems. And every single problem is PhD or even advanced research level problems.
Yeah, I mean, there are no humans that can actually answer these, can get a good score. I mean, if you actually say, like, any given human, what's the best that any human could score? I mean, I'd say maybe 5% optimistically.
Yeah.
So this is much harder than what any human can do. It's incredibly difficult. And you can see from the types of questions. Like, you might be incredible in linguistics or mathematics or chemistry or physics or any one of a number of subjects, but you're not going to be at a postgrad level in everything. And GROK 4 is a postgrad level in everything. Like, it's just, some of these things are just worth repeating. Like, GROK 4 is postgraduate, like PhD level in everything. Better than PhD, but like most PhDs would fail. So it's better that said, I mean, at least with respect to academic questions, I want to just emphasize this point. With respect to academic questions, GROK 4 is better than PhD level in every subject, no exceptions. Now, this doesn't mean that at times it may lack common sense, and it has not yet invented new technologies or discovered new physics, but that is just a matter of time.
Mm-hmm.
I think it may discover new technologies as soon as later this year, and I would be shocked if it has not done so next year. So I would expect GROK to, literally discover new technologies that are actually useful no later than next year and maybe end of this year. And it might discover new physics next year. And within 2 years, I'd say almost certainly. So just let that sink in. Yeah.
So so I guess we can talk about what's behind the scene of GROK 4. As Jimmy mentioned, we actually throwing a lot of compute into this training. When it started, it's only also a single digit. Sorry, the previous slide. Sorry. Yeah, it's only a single digit number. But as you start putting in more and more training compute, it started to gradually become smarter and smarter, and eventually solved a quarter of the HLE problems. And this is without any tools. The next thing we did was to adding tools capabilities to the model. And unlike GROK 3, I think GROK 3 actually is able to use CRO as well, but here we actually make it more native in the sense that we put the tools into training. GROK 3 was only relying on generalization. Here, we actually put the tools into training. And it turns out this significantly improves the model's capability of using those tools.
Yeah, I remember we had like deep search back in the days.
Yeah.
So how is this different?
Yeah, exactly. So deep search was exactly the GROK 3 reasoning model, but without any specific training, but we only asked it to use those tools. So compared to this, it was much weaker in terms of its tool capabilities.
And unreliable. Yeah.
And unreliable, yes.
And to be clear, these are still, I'd say, this is still fairly primitive tool use. If you compare it to, say, the tools that are used at Tesla or SpaceX, where you're using, finite element analysis and computational fluid dynamics, and you're able to run, or say like Tesla does, like crash simulations where the simulations are so close to reality that if the test doesn't match the simulation, you assume that the test article is wrong. That's how good the simulations are. So GROK is not currently using any of the tools, the really powerful tools that a company would use, but that is something that we will provide it with later this year. So we'll have the tools that a company has, and have very accurate physics simulator. Ultimately, the thing that'll make the biggest difference is being able to interact with the real world via humanoid robots. So you combine sort of GROK with Optimus, and it can actually interact with the real world and figure out if it can formulate an hypothesis and then confirm if that hypothesis is true or not. So we're really, I think about like where we are today. We're at the beginning of an immense intelligence explosion. We're in the intelligence Big Bang right now. And we're at the most interesting time to be alive of any time in history. Yeah. Now, that said, we need to make sure that the AI is a good AI, good GROK. And the thing that I think is most important for AI safety, at least my biological neural net tells me, the most important thing for AI is to be maximally truth-seeking. So this is a very fundamental. Like you can think of AI as this super genius child that ultimately will outsmart you, but you can still you can instill the right values and encourage it to be sort of, truthful, I don't know, honorable, good things like. The values you want to instill in a child that would ultimately grow up to be incredibly powerful. Yeah. So yeah. So this is really, I'd say, we say tools. These are still primitive tools, not the kind of tools that serious commercial companies use. But we will provide it with those tools, and I think it will be able to solve, with those tools, real-world technology problems. In fact, I'm certain of it. It's just a question of how long it takes.
Yes, exactly.
So is it just compute all you need, Tony?
Sorry?
Is it just compute all you need at this point?
Well, you need compute plus the right tools, and then ultimately to be able to interact with the physical world.
Yes.
And then, we'll effectively have an economy that is, ultimately an economy that is thousands of times bigger than our current economy, or maybe millions of times. If you think of civilization as percentage completion of the Kardashev scale, where Kardashev 1 is using all the energy output of a planet, and Kardashev 2 is using all the energy output of a sun, and 3 is all the energy output of a galaxy. We're only, in my opinion, probably like closer to 1% of Kardashev 1 than we are to 10%. So like maybe a point or 1 or 2% of Kardashev 1. So we will get to most of the way, like 80-90% Kardashev 1, and then hopefully, if civilization doesn't self-annihilate, and then Kardashev 2, like it's the actual notion of a human economy, assuming civilization continues to progress, will seem very quaint in retrospect. It will seem like sort of cavemen throwing sticks into a fire level of economy. Compared to what the future will hold. It's very exciting. I've been at times kind of worried about like, well, is this seems like it's somewhat unnerving to have intelligence created that is far greater than our own. And will this be bad or good for humanity? It's like I think it'll be good. Most likely it'll be good. Yeah. Yeah, but I somewhat reconciled myself to the fact that even if it wasn't going to be good, I'd at least like to be alive to see it happen. So, yeah.
So actually, one yeah. Yeah, I think one technical problem that we still need to solve, besides just compute, is how do we unblock the data bottleneck? Because when we try to scale up the RL, in this case, we did invent a lot of new techniques, innovations, to allow us to figure out how to find a lot of challenging RL problems to work on. It's not just the problem itself needs to be challenging, but also it needs to be you also need to have like a reliable signal to tell the model you did it wrong, you did it right. This is the sort of the principle of reinforcement learning. And as the models get smarter and smarter, the number of cool problems or challenging problems will be less and less.
Yeah.
So it's going to be a new type of challenge that we need to surpass besides just compute. Yeah.
Yeah, we actually are running out of actual test questions to ask. So there's like even questions that are ridiculously hard, if not essentially impossible for humans, that are written down questions, are swiftly becoming trivial for AI. Mm-hmm. So then there's, but you know, the one thing that is an excellent judge of things is reality. So, because physics is the law, ultimately, everything else is a recommendation. You can't break physics. So the ultimate test, I think, for whether an AI is, the ultimate reasoning test is reality.
Yes.
So you invent a new technology, like say, improve the design of a car or a rocket, or create a new medication, mm-hmm. And does it work?
Yeah.
Does the rocket get to orbit? Does the car drive? Does the medicine work? Whatever the case may be, reality is the ultimate judge here. So it's going to be reinforcement learning, closing the loop around reality.
We asked the question, how do we even go further? So actually, we are thinking about now, with single agent, we're able to solve 40% of the problem. What if we have multiple agents running at the same time? So this is what's called test and compute. And as we scale up the test and compute, actually, we are able to solve almost more than 50% of the text-only subset of the HRE problems. So it's a remarkable achievement, I think. Yeah,
this is insanely difficult. These are so what we're saying is like a majority of the text-based of humanities, scarily named humanities last exam, GROK 4 can solve, and you can try it out for yourself. And with the GROK 4 Heavy, what it does is it spawns multiple agents in parallel, and all of those agents do work independently, and then they compare their work, and they decide which one. Like it's like a study group, and it's not as simple as majority vote, because often only one of the agents actually figures out the trick, or figures out the solution. But once they share the trick or figure out what the real nature of the problem is, they share that solution with the other agents, and then they essentially compare notes, and then yield an answer. Yeah. So that's the heavy part of GROK 4, is where you scale up the test time compute by roughly an order of magnitude, have multiple agents tackle the task, and then they compare their work, and they put forward what they think is the best result.